Okay, this is a basic math skills self-test. We're going to cover things like decimals and fractions and long division, proportions, square roots, ratios, the Cartesian coordinate plane, fractions, area, perimeter, transformations, negative and positive integers, reading a ruler, two-part problems, the order of operations, and range. If you don't know about some of these, that's okay. The way this is going to work is you're going to take a look at each problem, be given a few minutes to work it out yourself, and then see how you did. So we'll take a look at number one. This is supposed to be something like taking a look in the mirror as you walk out the door. It's just a quick check. How are you doing? So this self-test has 20 different problems for you to try. When you see a new problem, click on the stop sign that's up in the upper right-hand corner. This will pause the video. Try to work through the problem on a piece of scratch paper, and then click on the go sign up in the upper right-hand corner to restart the video, and you'll see the problem worked out. All right, number one, turn 0.850 into a fraction. Then simplify your answer. This is kind of a two-step thing. First, you have to make a fraction. Then you have to simplify your answer. Click on the stop sign, and then try to work it out yourself. Okay, let's see how you did. Well, first of all, this number right here represents a fraction, and we're going to try to turn it into one. Let's take a quick look at a couple of things that you do. You already know that 1/2 is the fraction for 0.5, and 1/2 is also 5/10, and that equals 0.5. So we're going to talk about how you can get there from there. So, all right, when you're looking at a decimal, it doesn't matter what the number is. You don't pay any attention to the decimal. The number is your numerator. For example, if you had 1.2, that would be equal to 12 is your numerator, and 10 would be your denominator. 10 because you only have one place after the decimal. If we were looking at something like 1.25, 125 would be your numerator, and since we only have two places after the decimal, you would have 100, that is 2 zeros, as your denominator. So let's take a look at 0.850 and turn it into a fraction. So our numerator would be 850, and our denominator would have 1, 2, 3 zeros in it, so it has 3 zeros, and all that comes after a 1. So there's the fraction. Now, how do we simplify this? Well, perhaps you already know that these 2 zeros are pretty worthless in this case, so because 850 is equal to 85 times 10, and 1,000 is equal to 100 times 10. So we can cancel out these two factors because they're the same in the numerator and the denominator. They don't turn to 0. They don't go away. They become the number 1. And so 85 times 1 is 85, and 100 times 1 is 100. Now, what do we do next? Well, we'll factor some more. 85 is the same thing as 5 times 17, and 100 is the same thing as 5 times 20. This 5 cancels with that 5, just becomes 1, and this becomes 1. And so we wind up having 17 over 20. That's the final fraction. If we did the top end bottom out on this puppy right here, we would get 0.85. We wouldn't get the 0 here. We would get 0.85 as our decimal. All right, number 2. Try to turn 3/8 into a decimal. Click on the stop sign, and then see how you did. All right, let's see how you did. This is nothing more than a long division problem, because 3/8 is really the same thing as 3 divided by 8. And the way you do a long division problem like that, we like to say top in, bottom out. So we create our way of doing long division. The top goes in, and the bottom goes out. 8 will not go into 3, so we'll add a 0 and then a decimal, and then we can add a 0 here. 3 times 8 is 24, so we'll put a 3 here. That becomes 24. And then we do our subtraction, and that leaves us with 6. And 8 will not go into 6, but it will go into 60, and it'll go into 67 times. This is kind of the value of having good knowledge of your multiplication tables, because 8 times 7 is 56. So we have 56. And we do the subtraction, and that leaves us with 4. 8 will not go into 4, but it will go into 40 exactly 5 times. 5 times 8 is 40, so we come in here and we stick a 40, and then it terminates with a 0. So our answer is 0.375. Now, a lot of students ask, why do I put a 0 in front of the decimal? Because if I were to just make something that looks like this and say 375, you see the decimal that's right here. However, somebody might skip over that, but if they see that there is a 0, they know that it's followed by a decimal. So the correct answer is 0.375. All right, turn the decimal answer that you got for the number 2 into a percentage. And percentage, by the way, means per 100. So that means per 100. Okay, click on the stop sign and then try it. All right, let's see how you did. The answer that you got was 0.375 in number 2, and all you have to do is shift the decimal 2 places to the right. So this becomes 1, that's the tens place, and that's the hundreds place. So the answer is 37.5%. Number 4, turn all units into feet. The rectangles are proportional. What is the length of x? Click on the stop sign. All right, let's see how you did. A couple of ways of setting up this proportion. We can compare 3 to 12, or we can compare 7 to x, or we can compare 3 to 7 and 12 to x. Doesn't really matter how you do it, as long as you keep everything straight. If I compare the length of the short side on the large rectangle to the length of the long side on the rectangle, it would look something like this. 12 over x equals, and I compared first the short side, then to the long side, 3 over 7. And then you simply come in and you cross multiply. 12 times 7 is 84. So that's 84. And if they are truly proportional, and we've been told that they are, we know that x times 3 is also equal to 84. So let's set that up and then solve that. So we have 3x equals 84. If I divide both sides of this equation, meaning that this is in balance, if I divide both sides of this by 3, I haven't changed the balance any. So we'll divide both sides by 3. And I wind up then being able to cancel this 3 with that 3. It just becomes 1, and this becomes 1. And so we wind up having x equals 84 over 3. And if you divide this is just a division problem, if you divide that, you come up with x equals 28. And we're talking about feet, so it would be 28 feet. So the correct answer is 28 feet. Number 5 is the same drawing, and you already know that x here is 28 feet, so we'll just go ahead and write that in. All units are in feet. What is the area of the larger proportional rectangle? Click on the stop button. Okay, let's see how you did. First of all, you had to know that to find the area of a rectangle, it's just length times width, or x times y. You just multiply these two directions, and they're in feet. So this would just simply be 12 feet times 28 feet. And that's going to equal, we're multiplying length in two different directions here, so we're going to get feet squared, and that would equal 336 feet squared. If you didn't tell me they were feet squared, it was wrong. Sometimes feet squared can be abbreviated with a little FT and a squared sign, or you could say square feet. Doesn't really matter how you do it, as long as you let the people know, let the people who are looking at your answer know that it's an area answer and it's in feet squared. All right, number 6. The square root of 50 is between what two consecutive numbers? Consecutive means they come right after each other, like 9 and 10, or 15 and 16. Those are consecutive numbers. All right, the square root of 50 is between what two consecutive numbers? Well, it turns out that the square root of 49 is a perfect square, is exactly equal to 7. And the square root of 64 is exactly equal to 8. 7 and 8 are consecutive numbers. The square root of 50 falls somewhere between the square root of 49 and the square root of 64, and so it falls over here somewhere. These triangles are proportional. What is the angle measure of the unknown acute angle? Click on the stop sign. Okay, let's see how you did. Every single triangle in the known universe has exactly 180 degrees in it if you are given that 360 degrees are in a circle. So if you total up this measure plus this measure plus this measure, it will equal 180 degrees. Well, if this is 25 degrees and they're proportional, then this is 25 degrees. And this little thing right here means that this is a 90-degree angle. Oh, it's 90 degrees. So what that means is that 90 degrees plus 25 degrees plus whatever this is, and we'll call this x. We use x for the unknown things. So x equals 180 degrees. All right. So 90 plus 25 plus x equals 180. If we take 90 degrees off of each side, then we subtract 90 from each side, we wind up with 25 degrees plus x degrees equals 90 degrees. Remember, we took 90 off of each side to keep the balance. Now if we subtract 25 from each side, we wind up with x equals 65 degrees. We could plug that back into our original and say, all right, if we called this 65 degrees, we could then add all these. 90 plus 25 plus 65 does equal 180 degrees. Make a sketch of the Cartesian coordinate plane, then sketch a circle that has a radius of 2 and is centered at the ordered pair 3, 3. Click on the stop sign. Okay, let's see how you did. Well, let's see. Make a sketch of the Cartesian coordinate plane. So we'll make an x-axis and we'll make a y-axis. Now, I didn't put over here I didn't include much room for the second quadrant, the third quadrant, or the fourth quadrant because everything will be in the first quadrant. 3, 3 would be in the third quadrant, and I'm only going to draw a circle that has a radius of 2. Okay, now I'll just freehand sketch in 1, 2, 3, and 1, 2, 3. So here would be the center, 3, 3, as indicated where it should be. And then we'll come over here, and I'm just going to place a couple of dots where my circle should be. And then I can kind of freehand draw a circle in here. It's not all that great, but it said sketch. And now what I have is a circle that has a diameter of 4, a radius of 2, and it is located, the center is at the ordered pair 3, 3. All right, number 9. Click on the stop sign. Try to multiply these two fractions. Okay, multiplying fractions is actually one of the easiest things to do with fractions. You simply just multiply the numerators. 1 times 3 is 3. and you multiply the denominators. 2 times 4 is 8. And so the correct answer is 3/8. So I would just multiply the numerators and multiply the denominators. Number 10, click on the stop sign. All right, 1/2 times 3/4. Let's see how you did. Turns out that when you're dividing by a fraction, you just flip that fraction over and multiply. So here we have 1/2 times 4/3. And then now it's just a straightforward multiplication problem. I have 1 times 4 is 4, and 2 times 3 is 6. I simplify this by saying 2 times... Okay, I simplify this by simply saying 2 times 2. That's another way of writing 4, as that's my numerator. And 6 is the same thing as 2 times 3. Times 3. Now I have a 2 in the numerator, and I have a 2 in the denominator, so they cancel each other out and become 1. And I wind up with 2/3 is the correct answer. So 2/3 is the simplified version of the correct answer. All right, let me show you a quick proof of why that works. All right, we have 1/2 divided by 3/4. Well, let's just use this as an example. 1/2 divided by 1/2. Intuitively, you know that 1/2 will go into 1/2 exactly one time. But look what happens. Here we go. I have 1/2 times, I flip over the 1/2 to be 2 over 1, and I wind up with 1 times 2 equals 2, and 2 times 1 equals 2, and any number over itself is exactly equal to 1, because what this really means right here is this is just 2 divided by 2, and 2 will go into 2 one time. Number 10, what's the area of the figure shown? Click on the stop sign. All right, let's see how you did. This is called a trapezoid, and the area, the formula, and formulas are kind of easy because you just plug in the numbers. The area for any trapezoid, also called a trapezium, the area for any trapezoid is base 1 plus base 2 times the height, all divided by 2. That's the formula. All right, and it doesn't matter which one you call base 1 or base 2. This happens to be a base, the bases are your parallel lines, and this happens to be a base. And if I add 4 to 5, I'll get 9, and if I add 5 to 4, I'll also get 9. So it doesn't really matter which one you call base 1 or base 2. So don't worry about that one. So 4 plus 5 is 9 times 3, all divided by 2. And this amount right here is length in the x direction, and this is length in the y direction. So these are feet, and these are feet. So I wind up with 27 feet squared divided by 2. And that then simplifies to 13.5 feet squared. Or you could say 13.5 feet squared. Both of those are correct. Make a sketch of the depiction below and then copy the figure across the y-axis. Click on the stop sign. All right, the y-axis is this one right here, and a copy would look something like this. And I'm just going to quickly sketch it. So if you do something that looks like that, you're in good shape. Sketch the drawing below and reflect the figure across the x-axis. Click on the stop sign. All right, this is the x-axis, and a copy would look something like this. So you notice that I have a little tail sticking out here, and on the top, and down here it's on the bottom because it's a reflection. It's as if this was a mirror. Number 14. What is the area and perimeter of a triangle that has 2 legs that are 6 feet and 8 feet and a hypotenuse that is 10 feet? Click on the stop sign. Okay, when I look at something like this, I come in and I draw a sketch so that I can visualize it. One of the legs is 6, one of the legs is 8, and everything's in feet, so I'm just going to leave the feet marks off. Remember, one little mark is feet. And that's 10. All right, perimeter, that one's pretty easy. That's just you add up the total distance around. And so 6 plus 8 plus 10 is 24 feet. We're just talking about distance, and that equals the perimeter. Area of a triangle is area equals 1/2 the base times the height. This would be our base, 8, and our height of our triangle would be 6. So I would multiply 1/2 times 6 times 8, and that will equal 24 feet squared. So if you got those two answers, then you're doing it right. Number 15, sketch a circle and label. Number 15, sketch a circle and label 3 main parts. All right. One of the parts of a circle is its center. Another part of the circle is its circumference, a special name for perimeter of a circle. Another part is its radius, from the center to the edge, or the circumference. Another part of the circle is its diameter. It's the length that goes from side to side, passing through the center. And another part of the circle is the area. Number 16, adding positive and negative numbers. Click on the stop sign. All right, let's visualize this. Here's a number line, and if I start at 10 on the number line, and I subtract a negative amount, subtracting a negative amount, taking away a negative, is a positive thing. So, taking away negative 10 means that I'll advance 10 more down the number line, and I would be at 20. And 20 plus 30 is 50. Another way I like to think about it is when I have a negative, then I use this negative to come over here. I turn it on its side, and I make that a positive. And if I've used it, then this goes away. And so now I have 10 plus 10 plus 30. Taking away a negative is a positive thing. All right, number 17, what are the measurements for the 4 below? Click on the stop sign. Okay, if you were to come in here and count these, you'd find out that there are 16 little marks between the 0 and the 1. So I have 16 little marks here, and they're the same 16 little marks from 1 to 2, and they're the same 16 little marks from 2 to 3, and so on. It's the same 16 little marks from 99 to 100. So, let's take a look at A. Now, we have 1, 2, 3, 4 little marks, and these are sixteenths, so A is 4/16. But 4/16 will simplify to 1/4. All right, if this is 4/16, then this would be 5/16, 6/16, 7/16, 8/16. And 8/16 simplifies to 1/2. And these are inches, by the way, 2 little marks. So if this is 8/16, then this is 9, 10, 11, 12, 13, 14. 14/16 is the same thing as 7/8. And these are inches. Now, this one gets a little tricky. So we have here, we're at 2 and 1/16. So the correct answer here is 2 and 1/16. There's another way of looking at this. If I were to count 1, 2, 3, 4, 5, 6, 7, 16, 1, 2, 3, 4, 5, 32, this would be 33/16. Well, 33/16 is the same thing as 2 and 1/16. Number 18. How many minutes are in 3/4 of an hour? Click on the stop sign. Well, the tricky part of this one is that there are 60 minutes in an hour, so if we multiply 60 times 3/4, that'll give us the right answer. So, how do we multiply a whole number times a fraction? Well, we could just put that over 1, and 60 times 3 is 180. And 1 times 4 is 4. And 4 goes into 180 exactly 45 times. And so there are 45 minutes and 3/4 of an hour. Number 19, Thomas charges $11 per hour for his handyman services. If he works 8 to 11 hours per day, or each day, for the week, Monday through Friday, what is the range of his gross pay? Well, before I tell you to click on the stop sign, let's take a look at a couple things here. Monday through Friday, that just means 5 days. And range, that means what's the least amount he could make to the most amount he could make. And gross pay, that just means what's the total amount of all of the money that he made. Maybe if he was working for somebody, they would take out some taxes and some withholdings and some things like that. But if you're working for yourself, you have to take care of that later. All right, now click on the stop sign, try to solve the problem. Okay, well, let's see. If he works, let's just kind of make a chart here. If he works on Monday and he works 8 hours, or he works 11 hours, which that's he either works 8 as a minimum or 11 as a maximum, and then he works 5 days each week, so we could say then he works 5 days, and he works 5 days. So this is 8 hours times 5 days would mean that he would work 40 hours as a minimum, and 11 times 5 is 55. So he would work 55 hours at a maximum. But he makes $11 an hour. And so we could come in and say that's $11 an hour. So 40 times 11 equals $440. It's the minimum he would make. Or 55 times 11, that's $605. So he makes either 440 as the minimum or 605 as the maximum. That's the range. That's a $65 range. Number 20. This is order of operations thing, so figure out what to do. Press the stop button and come back. All right, let's see how you did. Well, order of operations tells you the first thing that you do is that which is inside the parentheses, so we'll multiply these two fractions. And the tricky part here was that you looked and you said, oh, that's fractions multiplying times a decimal. How do I do that? Well, 3 times 7 is 21, and 7 times 3 is 21. And so you're multiplying 21 over 21 times 3.7. And you should know that any number over itself is exactly equal to 1. So this is 1 times 3.7. So while it looked tricky, it really isn't. So the correct answer is 3.7. All right, this is the end. You are now ready to try other basic math self-tests. You may contact me at alanmorris@yahoo.com.